Here's our game plan. We're going to follow an attacker's journey through a few key phases. We've got discover, then access, followed by abuse and extract. And once we know how the bad guys operate, we'll switch gears and talk about the defender's playbook. All right, let's get into it.
All right, kicking things off with Phase 1, Discover. Think of this as the recon phase. Before you do anything else, you gotta map out the territory. It's like the first rule of any operation. Know your target inside and out.
So, what are we even mapping here? Well, in the security world, we call this the attack surface. And the best way to picture it is to think of a website as a giant building. Every single directory, every login portal, every API, even those upload your photo here forms, they're all potential doors and windows. And you know, the bigger and more complicated the building, the more chances you have to find one that's unlocked.
And the recon can start with something that seems almost ridiculously simple. This little command here, curl. It's basically the digital equivalent of walking up to that building and just reading the plaque by the front door. You're not trying to break in, you're just asking, hey, what's going on here? And believe it or not, the server will often just tell you. It'll hand over all sorts of juicy details, like what software it's running. And once an attacker knows that, they can just go look up a list of known exploits for that exact version. It's that easy to get started.
Okay, so we've read the plaque, now it's time to start jiggling some doorknobs. This next command, it takes a massive list of common directory names and just tries them all. It's like walking down a hallway, trying every single door, and the server's response tells you what you found. A 200 response? That's a bingo. The door's open, the page is real. A 301? That's a redirect, pointing you to another door. And a 403? That's a forbidden, that's a locked door. But even a locked door is a huge clue, right? It tells you something valuable is probably behind it.
And this is where things get really interesting. See, a smart attacker doesn't just focus on the main building, www.whatever.com. They hunt for subdomains. These are like finding other, smaller buildings on the same property that maybe aren't as well guarded. You find something like dev.target.com or staging.target.com. These are often development or testing servers. They were never meant for public eyes, so guess what? Their security is often way, way weaker.
So, our map is pretty detailed now. We know the layout. Now for the fun part, actually getting inside. Welcome to Phase 2, Access. It's all about finding that key or picking the lock. And you'd be surprised how often the easiest way in is just the front door. Seriously, attackers are always on the lookout for the easy wins, the low-hanging fruit. I'm talking about default credentials that nobody ever bothered to change, login pages that'll let you guess a password 1,000,000 times without locking you out, stuff like that. These are basically the doors that were left unlocked.
So here's what that looks like in the real world. This is a classic brute force attack. You take a tool like Hydra, you give it a username you know exists, like admin, and you feed it a giant list of common passwords. This example is using a list of 10,000, and the tool just tries them, one by one, over and over. If the website doesn't have a system to stop you after, say, 5 bad guesses, then it's really just a waiting game.
Now, a smarter, more efficient way to do this is something called credential stuffing. This one is brilliant because it preys on a really common human weakness. We reuse our passwords. Attackers get their hands on these huge dumps of usernames and passwords from other big data breaches, and then they just automate the process of trying those same combinations on other websites. They're betting you use the same password for your social media as you did for their target site. And honestly, it works a scary amount of the time.
But what if you just can't crack the password? What then? Well, if you can't pick the lock, you steal the keycard. See, after you log into a site, the server gives your browser a little temporary key called a session token. It's what keeps you logged in as you click around. If that token isn't secured properly, and often it isn't, an attacker can snatch it. And once they have it, they can just present it to the server and walk right in. No password needed. They're you.
Okay, let's pause. The attacker is in. They've bypassed the login. But just getting inside the building is rarely the end game. Now we hit Phase 3, Abuse and Extract. This is where they go from being an intruder to being the one in control. It's about owning the system and taking what they came for. And one of the absolute holy grails for an attacker is finding a file upload vulnerability. This is so powerful. They find a totally normal feature, like where you'd upload a profile picture. But instead of a picture, they upload a little piece of malicious code, a web shell. If the server is badly configured and just accepts it, boom, game over. That leads to something called remote code execution, or RCE. And that means exactly what it sounds like. The attacker can now run any command they want directly on the server. They don't just have access to the building anymore, they own it.
And the process is surprisingly straightforward. First,
You upload your weaponized file. Next, you just have to figure out where on the server it got saved. Once you know the path, you just visit that URL in your browser. That simple act of visiting the page triggers your code, and from there, you can start executing commands. It's crazy, right? A totally innocent feature gets turned into a wide-open backdoor.
All right, let's talk about another absolute classic, devastating attack, SQL injection. This is genius in its simplicity. So on the left, you see a normal, boring database query. It's asking the database for the user with an ID of 1. Simple enough. But look at the right. The attacker has sneakily added just a little extra bit of logic, or 1 equals 1. Now think about that. When is 1 not equal to 1? Never. So that condition is always true. You've just tricked the database into giving you way more than it was supposed to.
And you can use that same kind of logic to just walk right past a login screen. It's incredible. An attacker might type something like admin _ into the username field. That little double dash at the end? In the SQL language, that means ignore everything else on this line. So the part of the code that was about to check for the password, it just gets ignored. Poof. The database sees login the user named admin, and that's it. It logs them in. No password necessary.
So think about this. You've just bypassed the login. You are now logged in as the admin, the most powerful user on the entire system. But what's the real goal? What do you do with all this power? What's the end game?
Well, the end game is total data exfiltration, and it's all about automation. Once an attacker finds even one tiny little spot that's vulnerable to SQL injection, they bring out the big guns. A tool like SQL Map is basically the Swiss Army knife for this stuff. You just point it at the vulnerable URL, and it does all the hard work, systematically pulling down the entire database, every table, every row, every piece of data.
And the fallout from this is just catastrophic. We're not talking about a little bit of data. We're talking about everything. A full dump of your user tables, password hashes they can take offline to crack at their leisure, secret API keys, session tokens, the works. This is it. This is the crown jewels. This is what they were looking for from the very beginning.
Okay, so now that we've seen how the attack works from start to finish, we can finally talk about how to stop it. Because really, understanding the attacker's playbook is the absolute first step to building a solid defense.
And the good news is, for every single attack we've looked at, there's a specific defense. To stop that crazy SQL injection, developers use something called prepared statements. It's a way of telling the database, hey, this stuff from the user is just data. Don't you dare try to run it as a command. That file upload vulnerability? You need strong validation on the server side, actually checking the file's contents to make sure an evil script isn't just pretending to be a JPEG. And that brute force attack? That's what rate limiting and CAPTCHAs are for, to slow those automated tools down so much they become useless. It's all about building your defenses in layers.
So let's just run through that workflow one last time. It starts with enumeration, mapping the whole attack surface. Then they find and attack weak spots in authentication. After that, they hunt for the deeper exploits, like file uploads and SQL injection. And finally, they extract the valuable data and escalate their control. See? It's a logical, step-by-step process.
And if there's one thing you take away from all of this, let it be this. Methodology beats randomness every single time. It doesn't matter if you're attacking or defending. The most effective hacks and the strongest defenses are a result of a systematic, thoughtful process. They don't happen by accident.
And that's our look at a web attack methodology. Thanks for watching.